Welcome to lesson 6. In this lesson we are going to explore our home network in Barcelona configuration, which is this router. This is a specific configuration which has two local area networks. One of them is connected to Ethernet 2 and has a subnet of 192.168.89.0/24, and the other one is 192.168.90.0/24. We have Ethernet 3 here, which is the host only, and we have Ethernet 1, which is connected to the ISP router, and it has internet connectivity. What is the difference between these two LANs? The LAN, which is 89 and on the left side, has only internet connectivity and does not have any VPN network connectivity. LAN, which is 192.168.19.0, tunnels all of its traffic through the VPN tunnel, which is the Paris HQ headquarter network, and then this network tunnels the rest of the traffic through the tunnels if they need to go to Berlin or London, or it tunnels it directly to the ISP if this 90/0 network needs to reach internet. If you look on the tunnel configuration, the endpoint tunnel IP address on the Barcelona home router should be 10.10.10.50/24. As you already know how to configure the WireGuard tunnels between the Mikrotik routers, we are not going to recreate it again. All the configuration are already created, and we are going to check what are the specific settings required to make this configuration working. So if we open the Paris office headquarter router configuration, we can see that I have already added Barcelona home router configuration peer settings. If I double click on it, I give it a name, a peer for Barcelona home. The interface is WireGuard server 1. We have only one interface. The public key we have generated as the following. The allowed IP address is 10.10.10.50/32, which is the far end side, which is the Barcelona router. The pre-shared key, the persistent keep alive, and the responder tick is on. If we look into the routing table, IP routing, we see that we didn't add any new routes, and we will explore why in upcoming minutes of the lesson. Let's see what is the Barcelona router configuration. The Barcelona office configuration has assigned IP address of 10.10.10.50/24 on its WireGuard interface. Let's see its configuration. We have a WireGuard interface with the following configuration and the public key. And in the peer configuration, we have the following settings: new peer to Paris HQ office. Interface is the interface to Paris office. Public key. We have specified the endpoint IP address, which is our Paris router 1 interface IP address. It's UDP port 443, and we have allowed all IP addresses, and we have allowed 192.168 should be here 3.0/24. 3.0/24 is our local network in the Paris office. We have specified the pre-shared key, and we didn't put any tick on the responder as we are not this server of the VPN. If we look into the IP routes, we have two default gateways. One of them goes through the tunnel and the other one goes directly to the ISP. If we look on our configuration, one will go through the tunnel and the other one goes through the ISP, which is 172.16.10.1. Let's check the configuration, 172.16.10.1. And the other one is the VPN far inside, which is the Paris headquarters. The rest configurations are dynamic. We have created two bridges, which is bridge with IP address of 89 and the bridge with IP address of 90. And we have assigned the subnets of 192.168.89.0/24 and 19.0/24 to these two bridges. If we look into the bridge configurations, you can see that we have two bridges. And we have assigned ports Ethernet 2 to bridge with subnet of 89 and Ethernet 4 to bridge with subnet of 90. We have created two DHCP servers and assigned it to each of these bridges. If we look into the firewall configuration, we see the standard configuration that we have seen on the previous lessons for London and Berlin office networks. If we look into the NAT configuration, we will come to the NAT a little bit later, and Mangle configuration, which we will also discuss a little bit later. If we look into the interface configuration, we can see that we have interface list with the LAN interface list, where we have assigned bridge 89 and bridge 90. And we have one interface list where we have assigned Ethernet 1, which is the port which is looking to the internet, and WireGuard 1, which is the VPN tunnel to the Paris headquarters office. If we export the configuration to see what other settings might be available, we can see that we don't have any other settings. So now let's go and understand how it works. We again go to IP firewall. Now let's explore the NAT rules. So normally for the network, which is 192.168.89.0, we have a direct internet connectivity via the ISP router. We have created a source NAT rule on the NAT tab without interface Ether1, nothing in advanced, nothing in extra, and action is masquerade. What does it mean? It means that all of the traffic which wants to go to the internet will be processed with this rule and netted. And this net rule is second in sequence. But we have another rule which is the first in sequence, means it will be processed first. Let's see what is inside. Source NAT with the source IP address of 192.168.90.0/24, which is our left side computer configuration, which should tunnel all of its traffic through the VPN to the Paris headquarters. And we say here that the source IP address, which is on the left side, and the destination of this traffic is the VPN gateway interface, nothing in advanced, extra action, and we say masquerade. So if traffic is destined with the source IP address of 90.0/24, it will go to the tunnel of the VPN, and we will have to masquerade it through the VPN. What does it mean? For the HQ office, our local area network of 192.168.90.0 will not be visible. The HQ office will see our far end IP address of 10.10.10.50/24. So HQ office normally will not see our 90.0 network, will not see 89.0 network, will not see anything. It will see just 10.10.10.50/24, which is the IP address of our WireGuard VPN. If we look into the IP routes configuration, we can see that we have two default routes, and rest of the routes are dynamic, active, connected. So these routes were created based on the IP addresses which are assigned to VPN interface, Ethernet interface, and these two bridges. So now let's test if the configuration is working as expected. We have here the Windows 11 Your PC no tunnel, which is the left PC. Something happened to it. Let's try to reopen it. Let's check its IP address, say ipconfig. As you can see, it got the IP address on the network of 89.254. Let's check if it can ping the internet. Yes, it can. Let's check the trace route to network 192.168.11.1, which is our another home router in the chain with the EVNG router. As you can see, it goes to the gateway of 89.0, which is local area network for this computer. Then it goes to 172.16.10.1, which is the ISP far end remote IP address or default gateway. Then it goes to 192.168.13.1, which is my home router. Then it goes to 192.168.11.1, which is the router behind my home router. So we can see that nothing or no traffic goes via the tunnel. And at the same time, these computers should not be able to ping the server. Which server? This server, 192.168.3.100. Let's check. Ping 192.168.3.100. Why? Because this network uses for its default gateway the ISP remote far end, and the ISP doesn't know about the network 192.168.3.100. That's why it's sent it to the next default gateway, and that default gateway eventually reaches my local real ISP, and that ISP drops this packet. So as you can see, destination host is unreachable. Let's bring it down and let's see if the tunnel computer is able to ping the server. Let's check its IP address, ipconfig. It got the IP address on the network of 19.254. Let's say ping 192.168.3.100. As you can see, it can ping the server. Let's make a trace route to 192.168.11.1, which is one of my routers behind this topology. As you can see, it goes first to 90.1, which is this local area network default gateway. Then it goes to 10.10.10.1, which is the VPN IP address of the Paris interface. then it goes to 172.16.3.1, which is the Paris router remote default gateway. Then it goes to 192.168.11.1, which is my second home router. So as you can see, this network cannot reach internet. 192.168.19.0 cannot reach internet via its own WAN interface, but it can reach internet via the Paris tunnel. At the same time, it can reach other networks like London office LAN and Berlin office LAN using VPN tunnel of the Paris headquarter network. Okay, important thing to note here. We are now here on the mangle tab of the firewall. If we want for the traffic of 192.168.90.0/24 to be routed just through the tunnel, we have to do some manipulation with this traffic. What kind of manipulations? If we open the IP routes table, we see that we have two default gateways. One of them is 172.16.10.1, which is the ISP router, and we have 10.10.10.1, which is our headquarter VPN tunnel interface IP address. And if we look into its configuration, we can see that we have a destination address of 0.0.0/0. Gateway is the Paris headquarter VPN IP address. And we have chosen here some kind of routing table called routing tables Paris headquarter. Where does it come from? It comes from here. In the mangle tab, we are able to modify the first packet of the connection. Let's see the rule which I have added here. We have a rule which in the chain of pre-routing. What does it mean? It means that before we do any routing, any forwarding activities, we are checking status of this packet. If this packet has a source IP address of 192.168.90.0/24 and we didn't mark that packet with any connection mark, and this is the first packet which has a connection state of new, we are going to do something with this packet, and we would say we will mark this connection with a new connection mark, which is connection mark from 192.168.19.0/24. And then we put a tick here which says pass-through. Pass-through means that after we mark it, we allow some below rules on this mangle to also do something with this packet. The next rule which is active is this one. Let's open it. Let's go to the general tab and see. This rule says, also in the chain of pre-routing, before we did anything, that if a packet with a source IP address of 192.168.19.0/24 network and already marked, which has a connection mark of 192.168.90.0/24, and we are going to do something with this packet. We are going to say action mark routing, and we are going to say that this packet should use a new routing mark, which is routing table Paris headquarter. Not main, but routing table Paris headquarter. What does it mean? We are forcing this packet and all the packets which belong to these connections to be routed or to use some kind of new routing mark or new routing table with this routing table Paris headquarter mark. And in the IP routing table, if we go again, we see that this routing table says the default gateway for the packets which are marked with routing table Paris HQ is this gateway instead of this gateway. By using this configuration, the router is routing packets which go to the default gateway instead of ISP router IP address of 192.168.10.1. It routes them to 10.10.10.1 of the Paris headquarter VPN tunnel. Let's check if we disable these rules will the routing go through the tunnel. This one is tunnel configuration. Let's check again. The trace route, how it goes. As you can see, it goes through the tunnel. Let's disable one of these rules, which was routing. And let's try again if we are able to go the same way. As you can see, after disabling the mark routing rule, the packet goes directly using the main routing table, and it goes directly to the ISP and has no any capability to go via the tunnel. Let's enable it and check again. As you can see, now it goes through the tunnel. We have some other rules here, which I will just briefly explain you. We have rules like accept with a comment which says accept all new market connection from 192.168.90.1/24 network to 192.168.90.1 interface like ICMP. You can additionally add this rule, which is in the pre-routing chain with the destination IP address is the default gateway of the bridge with 90.1 IP address, which has a connection mark of this one, which we marked here. We say accept. What does it mean? It means that if we will try to ping 192.168.90.1, without this rule, we will not be able to ping it. Let's check. Let's say ping 192.168.90.1. As you can see, we are not able to ping it. Let's enable the rule. Cancel and try again. As you can see, now we can ping and we even see some packets going on. Why we are not able to ping without this rule? Because in the pre-routing chain, we have a rule which says that if the packet with the source IP address of 192.168.90.1 is trying to ping something, it should go through the VPN tunnel. And if it goes through the VPN tunnel, it's not able to ping even its own gateway. That's why this rule allows to ping its own gateway. Plus, if you have, let's say, a Winbox on this computer, you will be able to access your router to configure via Winbox, and this rule will also allow to do it. Okay, this is all what I wanted to show you in this lesson. If you have any questions, you can ask them in the comment sections of this video. See you on the next lesson. I highly recommend subscribing to my YouTube channel so that you don't miss any new lessons or setup guides that I release.